Hey guys, we're still in 4.3. Let's work with some letters. This part A says simplify each of the following, and this is probably what an 8th grader would do. Okay, so first, if we have any double negatives beside each other, you change them to positives, but we don't. Second, there's parentheses, and we need to get rid of them. On the page before, it said that negatives do distribute in the parentheses. So, this 9 is going to stay here, but then this negative gets distributed to both of these. And this regular 4 becomes a big fat minus 4. Then, when I distribute this negative to this negative 7x, look what happens. A negative from the outside with the negative 7x from the inside. These double negatives make a plusative. So we get 9 minus 4 plusative 7x. And again, the reason we got that plusative is because this negative on the outside, when I distribute it and multiply it with this negative 7x, we get positive. Okay, then like terms are the ones with the same butts. And these naked numbers have the same butts. They don't got nothing on them. But then the 7x has an x on its butt. So he's not like the others. Okay, so let's combine like terms. 9 minus 4. Bye. Bring down the plus 7x. Plus 7x. Hey, done with that problem. Okay, let's go to part B. It's kind of awkward, but we're going to do it the same way. Since there's a parentheses, the very first term just drops down. Then after that, the negative applies to everything. And this negative on the outside of this parentheses, it makes minus, then this negative x, and that's eventually going to turn into a positive. Then we have, when this negative hits this negative y, I'm going to have minus a minus y, and that'll eventually become a positive. No parentheses. I don't know what happened. Okay, so these two double negatives make positives. Plusatives. Woo. Okay, another way to think of this is anytime you have a negative on the outside, it changes everything on the inside. So in a second, these negative on the x and negative on the y should turn into a plus. And holy poop, they did. Okay, so we got x plus y. Okay, now we're going to add the like terms, the ones with the same butts, as in these x's. So this is a pretend 1x. Plus another pretend 1x is 2x. And there's no other y, so plus y. Yes. Okay. Let's look at part A on these word problems. It says, in each of the following problems, write an addition or subtraction statement and then solve the problem. So it says the hottest temperature ever recorded in a certain state was 123 degrees Fahrenheit. It was recorded on blah, 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 July 6, 1936. Okay, less than 5 months earlier, on February 15th night, the lowest temperature in the state's history was negative 57 Fahrenheit. What is the difference between the hottest and the lowest temperatures? Okay, so the question asks for what is the difference? That means minus. Between the hottest temperatures, which was this 123. My bad, 123. I don't know what just happened. And the lowest is negative 57. So what is the difference? So the hottest is 123. Then difference means we have to put a minus. Then the lowest is negative 57. So that's our addition or subtraction statement. And then let's see, It says, and then solve the problem. So these two double negatives make a plus, and it should turn into 180. Okay, let's look at part B. Part B says the temperature was -5, and then it rose by 16. What is the new temperature? Okay, so we started with -5, but then rose means plus. Keep leaving the L out, so plus. Then it says 16, so we rose by 16. So here's our addition or subtraction statement. And then the actual answer is whatever -5 plus 16 is, which is 11. Okay, let's look at part C. It says the temperature went down from 43 to -9. And it went down. If something goes down, do you plus to get there or do you minus to get there? Well, to go down, you have to minus. Okay, so let's make a little equation. We're going to have 43, because that's where we started at, minus, because we went down, and it went down some amount that we don't know. So we can say 43 minus x equals -9. Or you could say the opposite, that 43 plus 9 should give me my x value. Either way. Either way, 43 minus something bigger than itself is going to give you -9. So to figure out the bigger than yourself, you do 43 plus 9, and that's 52. So if we started with 43 degrees and we subtracted 52, we wind up at -9. So we fell 52 degrees. Okay, let's look at part D. It says Brooke's house has a temperature of 59. Okay. She put the heat on, and the temperature rose to 14. As she was still cold, Brooke lit a fire, which increased the temperature. Wait, hold on, my bad. Brooke's house started at 59. She put on the heat, and the heat rose. And it rose by 14. So we're going to say plus 14. On the last problem, we did not do that. We did not say 43 plus -9. Because it said it rose to -9. As in, something changed to get me -9. Whereas here, it says we actually rose up 14, and that's the change that happened. So we said 59 plus 59 plus 14 is 73. Then it says, as she was still cold, Brooke lit a fire, which increased the temperature by 11. So the 73 that we're now at, we increase it by 11. And we get 84 degrees. That's a hot house. Okay, so what was the temperature of the house? It was 84 degrees. And then if you're looking for our addition or subtraction statement, well, let's remember we started with 59. Then we added 14. And then hot dog, we added another 11. So if you need an addition or subtraction statement, there you go. Okay, let's look at these absolute value bars. Okay, we've kind of already talked about this, but absolute value bars make things positive. Let's say you have bars -3. That spits out a positive because it's actually just talking about the distance away from 0, not whether or not it was left or right, as in negative or positive. It's just talking about how many units away is -3 from 0. Okay, if it's already positive, it stays positive. Like, let's say you have the absolute value of 5. That's already positive, so it just stays positive when the bars disappear. And then negatives do not distribute into bars. So let's say I have negative bar 2. That does not make -2. That negative cannot distribute into the bars. Okay, so let's look at this one. I think it was on the front page. It says negative bars 33. Well, first you take care of the bars. The bars tell us 33 because it always pops out a positive. And then you attach that negative. Okay, let's say I have negative bars -33. Well, first you do the bars, and that tells us spit out a positive 33. Then you attach that negative on the outside, and the answer is still -33. So it doesn't matter whether the negative is inside the bars or not. Those bars still just produce a 33. And then you tack on the negative on the outside. Okay, let's look at part A. It says y equals bars x minus 3 bars. And it says find the value of y for each of the following. 7. Okay, so this 7, they didn't tell us, but it's supposed to be my x value. So we're going to plug a 7 in. 7 minus 3 in the bars is equal to y. And then this way we can find the value of y because it says y equals. Okay, so let's do some math. 7 minus 3 is 4 in the bars. And then anytime you have something in the bars, it spits out positive. So y equals 4. Yay! Let's look at B. We're still using the same equation, but now it says my x is -6. So we have y equals bars, -6 minus 3 bars. Then we do our math. -6 minus 3, that does not make a positive because it's a double negative. When I say double negatives, I mean there's a minus and then there's a minus right next to it. That's what a double negative is. Here, there's a number in between. So when you have a negative minus a number, it just makes a bigger negative. So -9. And that's equal to y. And then whatever you have in these bars, once you just get one final number, it spits out a positive no matter what. Y equals 9. But first we had to do our math first. So make sure you do the -6 minus 3 first. Then spit out the positive of whatever that was. Okay, part C says all of the values of x for which y is 1. Oh, shit. Okay. I dropped my kit. Okay. Let me write this down because I don't know what the heck that just said. Okay, so part C says all the values of x. Oh, no. So x is going to be the question mark here. For which y is 1. So it's saying 1, the number 1, is equal to the bars of x minus 3. Let's play around in our head. Obviously, whatever minus 3 that spits out 1 is going to be an answer. So what minus 3 spits out 1? Bars 4 minus 3. That spits out a 1 inside bars. And then the absolute value of 1 is just 1. So 4 is definitely an answer for x. That will give me a 1 when it pops out. But there's another number for x that I could subtract 3 from. And it results in a negative 1. So think about this for a second. What could I subtract 3 from that will give you a negative 1? And the answer is a 2. 2 minus 3 gives you negative 1. And then that negative 1 spits out a positive 1. So the question was, what values of x give a y value of 1? Well, there's 2 x values. We could have a 4, because 4 minus 3 is straight up 1. Or we could have 2 minus 3, because 2 minus 3 is negative 1. And then once you do the bars of that, it spits out a positive. So the first one was super easy to figure out. The second one, you kind of had to use your brain. Okay, let's look at this last thing, the charge field model. It's a lot like the chip model from the first page of notes. So let's see here on part A, it says demonstrate each of the following additions using the charge field model. Okay. So part A, it says negative 3 plus 6. So let's start with the negative, start with the negative 3. 1, 2, 3. Okay. Then we're going to tack on, we're going to draw 6 pluses. So let's draw 6 pluses. 1, 2, 3, 4, 5, 6. Okay. So we drew our first number, we drew our second number. Now, you're going to look for any pairs that cancel out. And there should be a pair of negatives and a pair of positives that cancel out. Sorry. All the negatives cancel out with the positives. My bad. Oh, this looks horrible. Let me do it on the back. Okay. This looks horrible. Okay, let me try again. The marker messed it up. Okay. I think you got the point I was trying to make, but it just looked horrible. Okay, so we have 3 negatives. 1. And 6 positives. 1, 2, 3. Okay, good. Then we circle the pairs that match. Like there's 3 negatives here, and there's 3 positives there. And then whatever is left out from outside the circle is your answer. So outside of the circle that I drew of pairs, I have 3 positives left over. So my answer is 3. Okay, let's do part B. Part B says negative 6 plus 3. So first we're going to draw the first number, 6 negatives. Then we're going to tack on the second number, 3 positives. Then we're going to circle the matching pairs. So there's 3 negatives and 3 positives. That makes matching pairs. And then whatever's left in that circle is your answer. So it looks like there's 3 negatives left. So that should be our answer. Okay, let's look at part C. Part C says negative 2, so draw 2 negatives. Then it says plus 2 more negatives, so draw 2 more negatives. Okay, now circle any pairs you have. And I don't have any matching pairs of pluses and minuses, so I don't get to circle anything. And then your answer is just what's left over. Well, I didn't circle any matching pairs that canceled out, so I just get negative 4. Yes. Okay, let's look at part D. Part D says 4 plus a negative 1. Let me do it over to here. Part D says 4 plus a negative 1. Okay, so that means we draw 4 positives. Then we draw a negative 1. Poop. I meant to say then we draw just a negative. 1 negative. Then we circle any pairs of matching negatives and positives. So it looks like we have 1 negative that can match up with that positive. Then you count what's left. And I have 1, 2, 3 positives left. So our answer is positive 3. Yay!